Welcome to the lesson on composite functions. Let's first review how we use function notation. Let's say I have a graph where a point is at 3, -1. Okay, if I ask you for f of 3, what I'm really saying is that x equals 3. And I want to know what y equals. I could also write it as a point. So if I go over to my graph and look at where my point is, I will see that my point's at 3, -1. So my answer is -1. I could either write it here or I could write it here. Remember that we're using function notation. So f of 3. Remember that x is your independent value, and your y is your dependent value. So when I write f of 3, I'm actually saying what is y in terms of x. So let's try an equation. So f of x equals -2x plus 5. Okay, so I'm going to graph this equation just to show you what it looks like. When graphing, I can always plug in 0 for x. If you plug in 0, you'll get 5. So 0, 5, about right there. And then I can use my slope, which is -2, right here, and really -2 over 1, and I can go down 2 over 1, down 2 over 1, and down 2 over 1. Okay. Now let's try our f of 3 again. So again, if I ask you what f of 3 is, remember the 3 is the independent value. I'm asking you to give me the solution or answer for y, which is dependent on 3. So I can also put 3 into the equation and calculate. -6 plus 5 will give me -1, which is the same answer we had before. The answer to f of 3 equals -1, regardless of whether I put it in the equation or if I use the graph. We're really only talking about a point. So now let's talk about functions and how we can use this to calculate composite functions. For our first problem, what you're going to do is you're going to add this problem to your assignment. Even though I'm working it with you, you're going to work it together, and then I'll give you a couple problems that you're going to work on your own. So for the first problem, I want you to find f of -3. So I'm simply going to take the equation, and wherever there is an x, put in the -3. So f of -3 would be -6 plus 1, which gives me -5. Okay, now, what if this problem actually looked like this? What if I said that the problem was 2 times f of -3? Okay. You would still find f of -3, but you would have a 2 in front of it. So your answer would be -10. What we did before was review how to evaluate f of -3. And then we did a new problem where you might have a number in front of the function notation where you had to multiply the answer to your f of -3 times some number in the front. Okay, let's try it again. For the second problem on your assignment, let's find f of 2 plus h of 1. So we're going to evaluate each function separately and then add them together. F of 2 is going to be 2x plus 1. So I'm going to put the 2 in for the x. I'm going to get 2 times 2 is 4 plus 1 is 5. Okay, so that was f of 2. Okay, h of 1 equals -3 times 1 plus 2. So that will give me a -1. Now it says to take the answers from both and add them together. So 5 from the first one and -1 from the second one will give me the answer of 4. So even though I had to do several calculations, at this point I'm only getting one answer. Okay, let's do number 3 of your assignment. So we're going to work it the same way. This time we're going to do f of x minus h of x. Notice they haven't given us a number to actually evaluate. So let's just take the expression. The expression is 2x plus 1 and -3x plus 2. So let's put that into its own expression or make it one whole expression. So f of x is 2x plus 1 minus all of h of x. The whole thing of h of x is -3x plus 2. So the reason why I put it in parentheses is to make sure that something in front of the parentheses is going to affect it or that I haven't missed anything. Okay? If it had been a plus, no, I wouldn't miss anything. But see this minus right here in the middle? The minus really means it's a -1 that needs to be distributed. So what I really need to do is write it 2x plus 1 and then distribute the -1. So a negative will make a plus 3x and then a -2 will be next. Now I just need to simplify. So 2x plus 3x is 5x. And 1 minus 2 is a -1. So my answer is 5x minus 1. No, I didn't get an actual answer because they weren't asking me to evaluate with a number. All this question asked was take the two expressions and put them together based on which operation they were asking for. Okay? Make sure you put number 3 in your assignment. Let's try another one. Okay, number 4 of your assignment. Let's work with some different operations. What if you had f of x times h of x? It's going to work the same way as the previous problem. We're going to take the expression for f of x and the one for h of x. Okay, again, put the parentheses around the expressions to make sure that you understand what to do. Notice that when you have parentheses around two binomials, a binomial is an expression with two terms. This means that you need to FOIL. So we're going to go back to Algebra 1 where you would FOIL two expressions. So 2x times negative 3x. Remember, I'm going to do the first and then the outer. Okay. So 2x times negative 3x is going to be negative 6x squared. 2x times 2 is 4x. Then I'm going to take the inside, so I'm going to go negative 3x and 2. So my answer is going to be negative 6x squared. I'm going to put the 4x and the 3x together, so that's going to make 1x. I can just write x, and then plus 2. Okay, so I can basically do several things with functions. I can evaluate them with a number, and then I can use function operations where I can multiply the expressions, subtract, add, whatever is asked of the problem. Okay. The other way that we could have written this problem is it might have looked like this. F times h of x. Still means that we're going to take the expression from f and the expression from h and multiply them together. Okay? All right, let's try a couple more problems. For problems 5, 6, and 7, I'm going to let you do these on your own. Go ahead and stop the video, work them out, and then play the video to see the answers. Okay, good luck and thanks for watching.